All right. What was the first part of equal pair? What was the first pair of equal parts that you have written?
AC is equal to BD. And I
AC is
think
equal to BD. Very good. Okay.
and I
Now,
think the next pair is AO is equal to BO.
1 second, Hiba. A, C, B, D. This is O. What all are they telling you? They are telling you that AB and CD bisect each other at O. So AB is this one. Just a minute. AB is this one. And CD is this one. And they bisect each other at O. And they're saying, state the 3 pairs of equal parts in the 2 triangles. Okay. So they have already first of all, what does bisect mean, Hiba? Bisect, when they bisect each other,
They divide.
Yeah, it means that this part is equal to this part. Okay, this from AO. Okay, AO is equal to BO. Okay,
Okay.
and they bisect each other, so that means AB is also bisected. That means divided into 2 equal halves. And CD is also bisected, divided into 2 equal halves. So this part, this half will be equal to this half. That's why we put 2 dashes over there, so that it denotes that this the 2 parts which have these 2 dashes, this and this, they are both equal. So let's say if somewhere over here, let's say this one also had 2 dashes, let's say, then that would mean that this is also equal to the other 2. Are you understanding what it means when we have 1 dash or 2 dashes? So when we have 1 dash, that means whatever has 1 dash, they're all equal to each other. So this is equal to this. Whatever has 2 dashes, they are equal. So let's say if I give you a triangle like this and another one like this, if I say this is equal to this, then I will put 1 dash on them to show that they are both equal to each other. If I say this is equal to this, okay, and this 3 dashes over here is equal to this, so that we can differentiate between them. We won't get confused. What if I put 2 dashes over here? Then it will be confusing. Is this one equal to this one? Right? So that's why we put a 3rd dash to differentiate it. Is it clear, Hiba?
Yes.
Okay. So can you tell me what all is already given? What all are the 3 pairs of equal parts?
AC is equal to BD.
How is AC equal to BD? Is it given to you that AC is equal to BD?
No.
What all is given to you? What all do you know till now? That is called given. What all do you know?
That CD to CD are equal and BA
Sorry?
are equal.
What?
Like CD is equal and AD is equal.
No. CD is bisected into 2 equal halves, right? It is bisected. Bisected means the 2 parts of it, the 2 halves of it, they are both equal. So CO is equal to DO. Is that clear?
Yes. Yes.
And what about the red line? Can you say anything about the red line?
AO is equal to BO.
BO, very good. Anything else that's equal here?
Second.
Think about angles.
BD is equal to CA.
How do you know that it's equal? Is it given anywhere?
Wait a second. AB is equal to CD.
No, that's not given. Are the red line and the blue line equal?
No.
Think about an angle over here. See, Hiba, till now, what all have you learned? You have learned 3 congruence criteria, right? Number
Yeah.
1, you have learned RHS. But for RHS, you need a right angle triangle. Over here, you don't have any right angle. So you cannot judge by this rule. Okay. The other one was SSS. So here you have 2 sides that are equal. The AO in this triangle is equal to BO in the other triangle. Similarly, this blue line and that blue line. So 2 sides in these 2 triangles are equal, but we don't know about the third side yet. So we can't say anything. Okay. We can't say anything. We don't know about the third side. Now about the third rule that we learned was the SAS. Do you remember?
Yeah, side angle side.
Yeah. So we have 2 sides. What about the angle between these 2 sides? SAS. So the angle between these 2 sides. Can you tell me the name of the angle between the 2 sides?
How do we
This one and
figure
this
out?
one, yes?
60 degree.
No, I'm not asking you for the measure, first of all. Secondly, you can't measure it. You can't just say it's measure unless and until you have properly measured it using a protractor. Have you measured it using a protractor?
No.
No, right? So we can't say anything about its measure. We can't guess its measure. Tell me the name of this. I'm asking you the name of this angle.
E.
This one. First, tell me the left one, okay?
Angle E.
Angle
E.
B. Are you saying B? Hello. Okay. Angle E. Okay. Hiba, where is the letter E? Is it there anywhere in the diagram? In the figure?
No.
No. Then from where did this E come?
Because I was trying to find the angle.
Okay, but where did the E come? There is already a point. That point over there, this point it already has a name. And which point is E? Which point are you talking about?
So how will we find out?
Hiba, I'm asking you, what am I asking? I am asking you the name of this angle. Can you name this angle? We have learned how to name angles, remember?
This angle will be AOC.
Very good, excellent. So angle AOC, fine. And what will be the name of the other angle, the opposite angle?
DOC.
BO?
D.
Very good. BOD, angle BOD. Are they equal or not?
They are equal.
How?
Because A is equal to B.
No.
O is equal to O. And
okay. Hiba, do you remember vertically opposite angles?
yes,
Are they vertically opposite angles or not?
they are
They are. And vertically opposite angles are
equal.
equal. So can I write it over here? Equal to?
But I said the same thing, that A is equal to B and O is equal to O and D is equal to C.
O is equal to O. But sir, you said A is equal to B. A and B are points. How can you say A is equal to B? That doesn't make any sense, does it?
Yeah.
If I say this point is equal to this point, does that make any sense?
No.
So when you're talking about something being equal to something, you say either a line segment is equal to another line segment, or you say one angle is equal to another angle. What else can be equal? Yes?
Yeah.
Is everything clear to you now, Hiba?
Yes.
Excuse me. Okay. So we have written the 3 pairs of equal parts. This is the first part of the 4th question. In Try These, page number 144. Okay, done.
Yes.
And I believe we did the second part in class, or did I? No, I think I gave it to you as homework itself. Yeah, what
Yeah.
will be the second one? Okay, so we will say, Hiba, what will we say? They are both congruent or not?
They are.
By which rule?
SAS.
By the SAS rule. Okay, can you tell me how will you answer the second part of this question? Which of the following statements are true?
The second one.
Very good.
But I still didn't understand the RHS rule.
The RHS rule.
Yeah.
Okay. See, bacha, the RHS rule says that if you have a right angle triangle, okay, basically 2 right angle triangles. Let me, yeah, okay. Let's say this is A, B, C, D, E, F, okay. And it is given to you that one, so you know that they are both right angle triangles. So this is 90, this is 90. You know that one side is equal to another side. Let me color them. That'll be easier for you to understand. This side is equal to this side. And the other side isn't given. See, if you had SAS rule over here, then what would you have? You would have, okay, this is one side, this is one angle, and this is one
This is
side.
another.
So you would have this side is equal to this side. In SAS rule, this is the SAS rule. If you are using it like this is a side, this is angle, this is side. If you have these 3 things given, that if I tell you that, Hiba, this is one angle, this is one side, they are both equal, and this side is equal to this side, then which rule are we using here?
SAS.
SAS rule. It doesn't matter even if it's 90 degrees. We are using the SAS rule because we are using one side, one angle, and one side. Okay. And the angle has to be the included angle between these 2 sides. So this is the SAS rule. But on the other hand, if it's given to you that it's a right angle triangle and the hypotenuse of both of these triangles, they are equal to each other, which means that this is equal to this, okay, and one side is equal and the hypotenuse are equal, then this is called the RHS rule. Right hypotenuse, and side. Hypotenuse is also a side, but we are talking about these 2 sides. Either of these 2 sides should be equal. Are you understanding it now?
Yeah. Can you show an example with like numbers?
Okay, example of RHS?
Yeah.
Okay.
With like numbers.
I got it. Okay. With numbers. All right, open page number 148.
I did.
Okay, can you see the try these?
Yeah.
Yeah.
Shall I
The
read?
first question, yeah.
In figure 7.32, measures of some parts of triangles are given by applying right hypotenuse side
Just say
congruence.
RHS.
RHS congruence rule state which pairs of triangles are congruent. In case of congruent triangles, rather result in symbolic form.
Yeah. Yeah. Which of these we have to just judge and tell which of these are congruent. So the first one, yes.
How?
Hiba, till now we've been doing this type of question, right? Look at page number 144. Look at the try these over there.
Yeah, but it wasn't. We weren't applying the RHS rule.
We were applying a different rule over there. Similarly, we now have to apply, it's the same question, but here we have to apply the RHS rule. Okay, just look at the two triangles. The first question, first part of try these, page number 148.
The first question is not. They are not equal.
They are not equal. Why? Because the right angle is there. Both of them are 90 degrees. Yes. Hypotenuse is there. Both of them are 6 centimeters. But one side is also supposed to be equal. But that is not equal in this case because one is 3 centimeters, the other is 2.5 centimeters. So are these two congruent?
No.
No. Got it?
Yeah.
Yeah, we'll do the other examples also so that it becomes clearer for you. Let me draw the second one over here. Just a sec. Okay, so Hiba, they are giving you that. I'm sorry that it doesn't look like a 90 degrees to you over here, but because it's a rough diagram, so it won't look like 90, but it is 90 degrees. Okay. Now,
The second one, they are they are equal.
congruent.
Yeah, they are congruent.
Because this is 2 centimeters, this is 2 centimeters. So we have a, let's go step by step. Let's go step by step. Right angle, yes or no?
Yes.
Yes. Hypotenuse equal or not?
Yeah.
Yeah, because both of them have the same hypotenuse, right?
Yeah, 3.5 centimeters.
Very good. Side equal or not?
Yeah, 2 centimeters.
Very good. So now can you tell me which side is congruent to which, sorry, how do I write it like this? Triangle dash is congruent to triangle dash. Can you tell me?
Triangle CBA.
CBA, okay. CBA is congruent to?
Congruent to wait a second, DAB.
Very good. Triangle DAB. Excellent, Hiba. So now you have gotten perfect at naming line segments and angles and triangles. Mashallah. Well done. Okay. So let's come to the third part of this question.
The right angle is there and the side is there, but the hypotenuse is not there, so it is not.
Hypotenuse is not there.
No.
Are you sure? First, tell me what is the hypotenuse for the triangle which is above?
6 centimeters.
No. the third part, there are two triangles, right?
Yeah.
Triangle ABC. What is the hypotenuse? Which one? Can you name the hypotenuse in this case?
X.
No. Name as in the third part. Are you, do you have the same question as I do? Wait, let me just share the screen. I think, or I'll just draw it over here. Wait.
I have the same one.
Yes. CABD 90, 90, 3.6, 3.6. Now tell me, what is the name of the hypotenuse for this triangle, above triangle?
Sorry, BAC.
BAC is the triangle. I am asking the name of the hypotenuse. Look at the purple triangle and tell me what is the hypotenuse that it has.
CA.
Sorry?
CA.
Okay. Bacha, what is hypotenuse? Hypotenuse means the side that is opposite to the right angle.
But that side doesn't have a name.
It doesn't have a name? What is
No.
AC?
The hypotenuse.
Now, what is the hypotenuse for the other triangle?
CA.
The pink triangle. What is the hypotenuse here?
CA.
CA. Are the hypotenuse of both the triangles equal or different?
Equal.
So do we have RHS rule applying over here?
Yeah, but there's no name for the hypotenuse.
Bacha, you just named them. You only told me that it's AC. Okay, I think Hiba, you are
Okay,
getting confused between the word name and measure. Okay. In each of the above two cases, you had a name also, you had a measure also. Over here, you don't have a measure. That means it's not given to you how much it is, like 4.2 or 5 point whatever. That's what you're saying, right?
Yeah.
That is not the name, bacha. That is the measure. Fine, they have not written the measure. You don't even need the measure. You need the name in this case. Is the hypotenuse for both of them same or not? Does it look the same to you?
Yeah.
Yeah, it is the same, right? It is ek hi line pe. It's the same line that is common between both these triangles. AC is common between both of them. Yes?
I understand now.
Yeah. So will they be congruent?
Yeah. BAC will be congruent to DAC.
Very good. Excellent. Shall we move on to the fourth one now? The fourth part of this question?
Yeah.
All right.
What does S mean in the fourth part?
In the fourth, what does S mean?
Yeah.
It is a point, bacha. Just like P is a point, Q is a point, R is a point. Similarly, S is a point.
But why does this triangle have 3 points? Sorry, 4 points.
How many points? Now, listen to my question very carefully. How many points does a triangle have?
3.
Sorry?
Oh, I understand now. I understood.
Very good. So, what did you understand?
There are 2 triangles in this.
Acha. Now tell me, fine, you understood that. But tell me, how many points does a triangle have?
3.
Acha. Remember your answer, okay? How many points does a line have?
Endless.
Endless. How many points does a line segment have?
1.
Line segment has only 1 point.
No, sorry, 2. Like 2.
A line segment has only 2 points. Fine. You're saying this is a point. This is also a point. What about this? This one is not a point over here. And what about over here? What about over here, over here, over here?
They
Are these
have
not points?
points.
Sorry?
They have endless points.
Yes. A line segment has how many points?
Endless.
Yes. You can say an infinite number of points. Fine?
Okay.
Okay. Now answer the previous question. How many points does a triangle have?
Endless.
Very good. How many vertices does a triangle have?
Endless.
No. What is a
No.
vertex, Batta? Vertex means corner.
Yeah, 3.
Very good. It is the point. See, a triangle has an infinite number of points, but vertex is that point where two line segments meet. Lines or line segments meet. Okay?
Okay, I understand.
Okay.
Yeah.
Now let's let's talk about the fourth question. Are they congruent? Okay, let's see it one by one. RHS. Right angle, yes or no?
Yes.
They both have a right angle? Yes. Do they both,
Yeah.
their hypotenuse is the same?
Yes.
Yes. Do they have one side that is the same?
Yes.
Yes. Which side is that?
QS and RS.
QS and RS are equal. How do you know they are equal? Is it given to you that they are equal?
No.
No. Then which other side do we have? What is the possibility? Yes.
They look equal.
Sorry?
They look equal.
Okay, they look equal, but we can't assume things when we are trying to prove something, right? That's the case in real life also and in maths also. Just by the looks of it, you can't say anything. You have to have the facts. What are the facts? The facts that are given to you are, okay, 90 degrees, given, done. 3 centimeters, 3 centimeters, clearly they are equal, done. The other side we need to see. So this triangle, apart from the hypotenuse, there are two other sides, yes? QS, and the other one RS. What is the other side?
PR.
PR is a hypotenuse, bacha. Apart from the hypotenuse, we have two other sides, yes?
PS.
PS, and in the other triangle, what is that side? PS. Yes, PS is common in both of them or not?
It is.
It is. So do we have a side that is equal or not?
Yeah, but how is it a side?
Acha. Let me draw it for you. Now look at this triangle, okay? What are the three sides of this triangle?
P, PQ.
That is the hypotenuse, okay. Then
PS.
PS.
And QS.
and QS. What did you ask just 1 minute ago? You said, how is PS a side?
Yeah.
Now you understood how it is a side?
Yeah.
It is a common side for both of these triangles. Whenever we have a common side, we see that it's equal. Obviously, it's common. So PS is obviously going to be equal to PS itself. Yes. So the side is equal. PS is equal to PS, which is a common side. Right?
Yeah.
So which triangle is congruent to which triangle here?
PQS is congruent to
Triangle
PRS.
PQS is congruent to triangle
PRS.
Very good.
Triangle
Priya.
PRS.
Hmm?
Triangle PRS.
Very good. Now, yeah. Okay.
Okay.
Hiba, your exam is day after tomorrow, yes?
Yeah.
And your portion is what? Chapter 6, 7, 8.
Yeah.
Okay.
Can we complete the exercise now?
Yeah. Okay. So, yeah, now we have to come to let's come to a new congruence rule. Till now, what all we have seen? First, we saw RHS. Then we saw
SSS.
HSS. Then
And then
SAS. Now we
SAS.
have a different one. ASA. What does this mean? That if you have two triangles.
Angle, side angle.
Yes, very good. You have two angles that are equal. This angle is equal to this angle. Okay. This angle is equal to this angle. You have two angles that are equal. And the included side, the side should be between these two angles. Okay. So it should be this side should be equal to this side.
Okay.
Then it's called an ASA congruence rule. Okay.
Okay. What about the angle on the top?
Sorry.
What about the angle on the top?
On the top. We don't require this. For the ASA rule, we only need three things. Yes. In fact, for any of these rules, you only need three things.
Yeah. So for ASA, we only need them on the base of the triangle.
It doesn't have to be on the base. I'm just showing it to you like that. It could be anything. It could be instead of this angle and this side, you could have this one. Let's say this angle is equal to this angle. Then the included side. What is the included side, bache? The included side is this one. Yeah. So it has to be like this. Got it?
Okay. Yeah.
Okay. Acha, Hiba, what if you have a side, you have an angle, you have a triangle, in which this angle is given to you, that these two angles are equal to each other, and then these two angles are equal to each other, but the side that is given is over here, this one. These two sides are equal. Can you apply ASA congruence rule?
No.
No, because the side is not between these two angles. But Hiba, tell me one thing. Just look at this triangle. Just only look at this triangle, okay? If you know two angles of a triangle, can you find the third angle?
Yeah.
How?
Like if the
okay,
red
let's say,
and the
let me give
blue.
you an example. Let's say this is 30 degrees and this is 50 degrees. Then the other angle will be? The third angle will okay, X, but what will the measure be? You will find it. And how much will it be?
Can I find and then tell you?
Tell me. That's what I'm asking. How are you going to find it?
X plus 30 plus 50 gives 180.
So you will say we are using the angle sum property. Yes?
Yeah.
So you don't know the third side, but you can find it. So you find it and tell me. Sorry,
Yeah,
third
sure.
angle.
Yeah.
Hiba, see, 50 plus 30 is how much?
6. Sorry, 80.
80? Yeah. So overall, this should be 180. 50 plus 30 plus
Yeah.
this thing should be 180. So 80
Yeah.
plus what will give you 180?
80 plus 100.
Very good. So this is 100 and this is 100. Now you don't need this third angle, okay? You don't need the one that was given on top. Now do you have ASA rule?
Yes.
Yes, now we have ASA rule. Angle, side,
So it's angle, side, and angle.
angle. Okay, got it?
Yeah.
Now let's come to the try these. Let's do one thing. You can do the try these as homework. Let's do the exercise now.
Okay.
Try these as homework. Page number 145. Hiba, please complete this homework and send it to me, okay?
Yeah, I will try.
Okay. Now let's come to, we're gonna come to the exercise. Wait a minute. Exercise 7.2, page number 149.
Okay. Which congruence criterion do you use in the following?
Okay, so what all is given? If you have a pencil, you can go and mark it in your textbook. Okay, like how I'm marking it over here. Let me mark it and you can do that in your textbook.
What does congruence criterion means? Like
Same thing, congruence rule. We
like
saw how many
SA.
till now? 4, yes?
Yeah, okay, understand.
So A, C, B, D, oops. This is D, E, F. Hiba. So can you read out the question?
Yeah. Given AC is equal to DF.
Okay, so AC is one sec. As you are reading it, start marking it in your triangles.
Okay.
Okay, how do you mark it? You mark it like this. AC is equal to DF. Done. One mark done. Like you have to put one dash. Next. Are you marking it simultaneously in your book?
Yeah. And then AB, we have to mark it 2 times.
Very good.
On both sides. And DE.
AB and DE. Very good. Next.
Yeah. And BC, we have to mark it 3 times. And EF also 3 times.
BC is equal to EF. Now, which rule does this look like?
RHS.
This is RHS.
No.
Then?
Sorry, no. It is SSS.
Very good. Side, SSS. Okay. This is the A part. Let's come to the B part.
Okay. Given ZX is equal to RP.
Mark it in your textbook. I'm not doing it here because it's going to take me time to draw the triangle. So mark it in your textbook.
Okay, I will do. What does angle PRQ equal to angle that mean?
PRQ. First, you see what is angle PRQ. Okay, fine. Let me just draw a rough one. Angle PRQ means which one? This one?
Yeah.
Yeah. So just mark it once like this. See, if in something like over here, when we use the ASA rule, remember, then in when you have to mark the other angle, you can use 2 strokes like this, just like we do in the line segments. We use 2 strokes in the line segments. Over here, you can use 2 strokes, but not over here, like when you have to use ASA rule. Okay, not in the B part. Only use 1 stroke because you have this just 1 angle over there.
Okay.
That is angle PRQ. Then what is angle XZY? Done, marked it.
Yeah.
Which rule is this?
This is RHS.
How is it RHS? Do you have a right angle over there?
No.
Then you have one side, one angle, another side. What does it look like?
Wait, can you repeat it again?
We have one side, one angle, and another side.
SAS.
SAS. C part.
Wait, I'm marking it.
Okay.
The C part is ASA rule.
ASA. Okay. One sec. Angle MLN. This one, just check if you have marked the correct one. Okay. MLN is this one. FGH is this one. NML. NML. This angle. And GF.
I didn't mark it correctly.
But
can you tell me how to mark them?
Okay. Which one did you कौन सा वाला आपसे गलत हो गया?
Both of them.
Both of them. Okay. हिबा एंगल MLN हमने क्या देखा था? It's saying angle MLN. ठीक है, हमने क्या देखा था कि जो बीच वाला पार्ट होता है, बीच वाला लेटर होता है, that is the vertex. This is your starting point. This is your ending point. So MLN, starting point is M, then you go to the vertex which is L. Let me use another color. Starting point is M, then you go to the vertex which is L, then you go to N. So कहाँ पे एंगल बन रहा है हमारा? L पे बन रहा है ना?
Yes.
Yes. Similarly, do the same thing for the other triangle.
Okay, wait a second. G, and then M, and then F.
What?
I was marking them.
Acha, okay.
Then ML is equal to.
Hiba, the second one, have you marked it properly?
Yeah.
The second angle?
Yeah.
Very good. Then ML is equal to FG. So ML is equal to FG. Which rule is this?
ASA.
ASA. Very good. 2 angles and included side. D part?
The D part is obviously RHS.
Very good, because we have one right angle, one hypotenuse, and one side. Okay.
Okay. Wait a second. Okay, we can continue.
Okay.
You want to show that triangle ART is corresponding to triangle PEN. If you have to use SSS criterion, then you need to show. First is AR.
AR is equal to what? If you are using SSS criterion, then AR should be equal to?
PE.
Very good. Next.
RT is equal to EN.
Very good.
AT is equal to PN.
Can you repeat?
AT is equal to PN.
Very good. Next. Okay. Have you marked this in your textbook? Please do it with a pencil, not with a pen.
Okay. If it is given that angle T is equal to angle N and you are to use SAS criterion, you need to have.
Okay. They are telling you something. Angle T is equal to angle N. Okay. So if you want, you can mark it. But if you want, you can just store it mentally also. Next, RT is equal to, so you have to use which one? SAS, right? Now you have to just use a little bit, you have to apply some brain into it. One sec. So, ATR,
I have a question.
Yes, Hiba.
Why are they specifically telling us that angle T is equal to angle N?
They're telling you that if this angle is equal to this angle, and you need to use SAS congruence rule, then which two sides do you need to show? You have one side, right? I'm sorry, you have one angle that is equal, that is given to you. Which other two sides do we need to know that they are equal so that we can use this rule?
Okay, understood now.
Which two sides will we be using?
RT and PN.
RT will be equal to?
RT will be equal to EN.
Very good. Next?
PN will be equal to AT.
Very good. That's all that they're asking.
Okay. If it is given that AT is equal to PN and you are to use ASA criteria, you need to have.
Okay. So you have to use ASA rule. ASA. So in this particular figure, you know that AT is equal to PN. So what else do you need to have? Two angles, right? Which two angles do you need to have?
AR is equal
angle,
to.
Name of the angle should be, how do we name angles, bache?
Angle AR.
Angle AR. Angle's name has two letters.
No, sorry. Angle A.
Yes.
Is equal to angle P.
Very good. Then?
Angle T is equal to angle N.
Very good. That's all. Okay.
We don't have to name the third one.
No. What do we need in ASA, bacha? We need only two angles and the included side. Yes?
Yeah.
So you have named the two angles.
Oh, okay, I understand.
Okay. See, now Heba, the third question. When you have to prove that some triangle is congruent to some triangle, you write it like this, like how they have written in the textbook. They have written some steps and some reasons. Yes. So like if you remember initially when we were doing this RHS rule and SSS also, then we used to do it like this. This side is equal to this side, so and so reason, we used to write it in the bracket. Yes. So similarly, you have to write it over here also. So PM is equal, they are telling you that you have to show, just look at the diagram carefully. What all things do you have? What all things are equal over there?
And a triangle AMP. Sorry, no. AMP is corresponding to
congruent to.
Yes, sorry, congruent to AMQ. In the following.
So just look at the triangle first. Look at the triangle. What all things are equal in the triangle?
AMP and AQM.
AMP is what?
No, sorry. AM is the common side.
Very
both
good,
sides.
very good. So AM is equal to AM, reason, common side. Just look at the third part of this question. AM is equal to AM, right? It's given over there.
Yeah.
In the reasons, you have to write common side. Reasons
Okay.
mean why are you writing this particular step? How are you saying this? Okay.
Okay.
Or in other words, what
P
leads you to say this? So just write common side. Next.
PM.
What?
PM is equal to QM.
QM. Reason? You will write over here given. In the reasons, you will write given. What do we mean by this? We mean that either it is given to us in the diagram, in the figure. Okay, it is given to us in the figure, right? They have marked it like this. Yes, so it is given to us in the figure. Given means they are already telling us. The question itself is telling us that they are equal. So that means given. So either it is given in the figure or it is given in the text, in the diagrams, in the question somewhere, it is written that they are equal. Then you write the reason as given.
Okay.
Okay, so write given over there.
I wrote.
Then
angle PMA is equal to angle QMA.
So look, as you are reading this, look at the diagram, the figure. Angle PMA is equal to angle QMA, yes or no?
Yes.
Very good.
Because
come on, say it.
Because they have the same side.
No, because it's given. It's given to you. Yes, because they have made the same two strokes over there, right? So that means it is given in the question itself.
Yes. Okay, I understand
now.
Triangle
so we have one sec. So we got this three parts. To show that something is congruent, you need three parts, right? So you got three parts. Now you will say that these two triangles are congruent. Reason? By which rule?
Wait a second. AMP and
triangle AMP and triangle AMQ are congruent by which rule? What should you write in the reasons?
SAS.
Very good. SAS.
But can you tell how?
How? SAS because this side is equal to this side. S. This angle is equal to this angle. A. This side is equal to itself, obviously.
Yeah.
Side SAS. This angle is between these two sides or not? Yes? It is included between the two sides, right?
Yeah.
Got it?
Yeah.
When you're done, come to the next question. Okay, but tell me one thing. In your chapter number 8, is the entire chapter coming or some portion of it coming?
The entire.
Okay.
Can you show another example of the fourth question in the third question, the fourth part?
Bacha, it's not something new. See, three sides are equal. I think you're getting confused in the fact that it's written along the other steps. See, how you're writing? You're writing PM Fine. PM is equal to QM. Angle PMA is equal to angle QMA. Whatever reason it is, you are writing over here. Fine. Then AM is equal to AM, reason being common side. Fine. Therefore, triangle AMP is congruent to triangle AMQ. Is this something new or we have been doing this till now?
It is. We have been doing it.
So this is the same thing that's written over there. Reason being by SAS rule.
But how do we find out that it is SAS?
Look at the sides, look at the angles, look at what all you have, look at what all you have written.
Okay, I understand. I understand now. I can identify because there is an angle, just one angle.
Yeah, just one angle, and not just one angle. You will say there's one side and one angle and then another side, and they are ordered in such a way that this angle is between those two sides. Yes.
Yeah.
This particular triangle, this angle is between these two sides.
Okay, I understand now.
Okay. Next, fourth question.
Can you wait a minute? I will draw a diagram for that question. Okay. In triangle ABC, and angle A is equal to 30 degrees, and angle B is equal to 40 degrees, and angle C is equal to 110 degrees. In triangle PQR, angle P is equal to 30 degrees, angle Q 40, and angle R 110 degrees. A student says that triangle ABC is congruent to triangle PQR by, we didn't learn this.
He is saying, the student is saying that, so till now what all we have seen, SSS, if three sides are equal, one angle is there, two sides are there, then it will be equal. Then you have two angles and in between them you have one side that will be equal. RHS also is there. So he's saying ki, why can't we say it like this, that if there are two triangles and this angle is this side, this angle is equal to this angle, this angle is equal to this angle, this angle is equal to this angle, why can't we say that they are equal? They are congruent. That's what he's saying. Are they congruent or not?
They are.
They are congruent. So that's what he's saying, that they are congruent by A congruence rule. That means angle. Can we say that they are congruent or can we not say that they are congruent?
They are congruent.
How?
Because all the angles are equal.
Okay. Let me give you an example, Iba. You have this particular angle or triangle. Let's say it's an equilateral triangle, okay?
Okay.
I am drawing another equilateral triangle over here. So are they both congruent or not?
Can you repeat it? Can you show it again?
We have two equilateral triangles. They are both equilateral. What is the meaning of equilateral?
As they are, all the angles are 60 degrees.
And all the sides are equal. If this is 2 centimeters, this is 2 centimeters, and this is also 2 centimeters. That means equilateral. 1, 1, 1. Fine. This is 1 centimeter, then this is also 1, and this is also 1. All the sides are equal. Fine. That is one thing. And the other thing is also that all the angles are also equal. So this angle is 60. This angle is 60 and this angle is 60. Similarly, this is also an equilateral triangle. So this angle is 60, this angle is 60, and this angle is 60. Now tell me, Are they congruent or not?
No, because
No,
the sides are different.
sides are different, but the angles are all equal.
Yeah.
Then, so we can't say just by if all the angles are equal. That is why there is no such thing as an AAA rule. There is no such thing. Why? Because if you take this triangle and let's say you expand it. How do I mean expand it? You do it, take it like this, right? The angles are still the same, but the side length has changed. So it's not congruent. So for it to be congruent, you need to have at least one side. At least one side should be there. Two angles, if two angles are there and one side is there, then we can say, but there is no such thing as AAA rule. Just only if you have three angles that are equal, you can't say that they are congruent because the sides could be bigger or smaller. Understood?
Yeah.
Fine. Let's come to the fifth question.
In the figure, the two triangles are congruent. The corresponding parts are marked. We can write a triangle RAT corresponding
Congruent.
Congruent to dash triangle.
Congruent to triangle what?
It will be OWN.
Acha. See it very carefully. RAT. What is the part that is, what is the angle that is corresponding to R?
WON.
Very good. Write it then. Triangle WON.
Okay, I've written it. Complete the congruence statement. Triangle ABC is
No, triangle BCA.
BCA congruent to triangle dash. BCA, so it will be T. Wait, let me see. BCA. BTA.
Very good. BTA. Next. Second part.
Triangle QRS.
Triangle QRS will be congruent to what? Now look very carefully, okay? Triangle
QT.
QRS should be congruent to?
QTP.
No.
No, it will be. Why is there a dot in S and Q?
That is to show that they are both equal.
Okay.
They don't usually put it over there, but it's just to show you.
It will be QPT.
Once again, QPT.
Yeah.
No. Okay, Hiba, do one thing. Try to think of them. Over here, you're being confused because the Q is joining them. Okay, let me show you. It's like this. Okay, now this is Q, this is P, this is T. I have not done anything. I have just separated the two triangles from each other. This is P, this is T. Now see what's happening. T, angle T is equal to which angle in the other triangle?
S.
Look very carefully at the other triangle.
Q.
Yes. angle T is equal to angle Q. Okay. Next, angle P in the first triangle. Angle P is equal to which angle in the second one?
R.
R. Okay. Then let's take this is A, two angles. Yes, two angles. And which is the side between those two angles? PT. So side PT is equal to which side?
QR.
QR. Now, can you tell me? They are saying triangle QRS, which is this one.
PTQ.
Triangle QRS. Yes, which one?
PTQ.
Again, wrong. QRS. Bacha Q. Which one? Which angle is corresponding to angle Q? Over here, look at angle Q, which is the red angle.
TPQ.
TPQ. Triangle TPQ, or you can say triangle QRS is congruent to triangle TPQ.
Okay.
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 So Hiba, whenever you have such questions where you're being confused just because the two triangles are very close to each other, or because they have a common point, or they are, a part of the same thing, then you can separate them like this. Okay.
Okay, I understand.
Next question. Okay, next question, Hiba. The seventh question. This will not. I don't think I think your teacher must have told you that this won't be coming. This type of question.
The seventh and eighth question is omitted.
Exactly. Okay, next to the ninth question.
In triangle ABC and PQR are to be congruent. Name one additional pair of corresponding parts. What criterion do you use? Can you give me 5 minutes? I will come and play Maghrib.
Okay, okay.
Go on with it.
Okay.
Okay, we can continue.
All right. Okay, so question number 9 है वो.
Yeah. What does this question mean?
See, Hiba, we want these two triangles, triangle ABC and triangle PQR, to be congruent.
Yeah.
But what are the two things that are equal which are given to you? Given. What all do you have as given? Tell me. Always write it like this, okay? In your answer, you have to write given. Tell.
That A and P are congruent.
No,
B
they are
and
not congruent. They are saying that if they are going to be congruent, you have to tell one additional pair of corresponding parts. Okay. What are the parts that are already given to you that are equal? Look at those two triangles and tell me what all is equal to each other.
ABC and PQR.
Angle B is equal to angle Q. Yes.
Yes.
Angle C is equal to
Angle R.
angle R. You have two. What are these two things? They are angles, right? What is the third thing that you need to show that they are both congruent?
A side.
A side. Very good. Which side?
AB.
AB. Why?
Because it is forming a 90 degree.
Okay, wait. Hiba, angle angle. These are two angles, A. And you said we need a side. That side should be where? Between the two angles, right?
Yeah.
That is what ASA means. That the
Yeah.
side should be between these two angles. So which side are we looking for?
The one between
What is it? What is it called?
side.
BC?
Yeah.
You
PQ.
need BC is equal to?
PQ.
No. Look at the other triangle and tell me. BC should be equal to?
QP.
QP.
Sorry. No, QR.
Very good. QR. Excellent. Which criteria did you use?
ASA.
Very good. ASA.
But
Are you understanding this?
But how did we get BC?
Okay. Hiba, we have two angles. Just a sec. They have given us two angles. One angle is this and other angle is this. You need, when you have two angles, what do you need? What else do you need?
A side that is in between the angles.
A side that is in between them. Which is the side that is between them?
S.
No, what is the name of the side? But look at the diagram in your textbook.
BC.
BC, that is why we have written BC.
Okay, I understand now.
And what will be the corresponding part in the other triangle for BC?
QR.
QR, very good. That is how we got QR. Got it now?
Yeah.
Very good. Now question number 10.
Explain why angle ABC is congruent to angle FED.
Triangle, bacha, triangle.
Triangle FED.
Yeah. Why are they congruent? Can you look at the things and tell me?
Yeah. Because B and E are 90 degrees.
Angle B. Say angle B.
Sorry. Angle B.
Hiba, I'll tell you one thing. When you say just B, it means the vertex B. Okay. B is a vertex, yes?
Yeah.
It means the vertex B. But if you say angle B, then it means the angle that is over there.
Okay, I understand.
So continue.
Angle B is equal to angle E because they are forming 90 degrees. And angle A and angle F are also equal.
Because it is given.
Because it is given. And angle D and C are equal because it is given.
Angle A and C?
No, sorry, D and C, D.
Side BC. Don't say angle, na? Say BC. BC is equal to?
Why do we have to say BC and not angle C and angle D?
Bacha, what is given to you? This thing that they have drawn, they have given this thing. This marking that is there, this denotes what? This marking is there on an angle or on a side?
On a side.
That's why it is side BC.
Okay, I understand.
BC is equal to?
DE.
DE. So which rule? Okay, this is also given. Now, which rule have you used here?
RHS.
RHS. What does RHS mean? RHS means right. Okay, fine. So this is right. All right. Hypotenuse you don't have. You have a side. This side you have, but you don't have hypotenuse. RHS means you have a right angle, a hypotenuse, and a side. But here you don't have a hypotenuse.
SAS.
SAS. What does SAS mean? SAS means you have two sides and one angle. Do you have two sides over here?
No.
What all do you have over here? Once again, tell me. What all things do you have?
We have a right angle, and we
Uh-huh.
have two two angles.
See, basically we have two angles and one side. Two angles and one side means which rule that we can use?
ASA.
ASA. But in ASA, what do we need? Side should be
In between the
in between them.
angles.
But over here,
Yeah.
is our side in between these two angles?
No.
No. Then what can we do? Do you remember one small trick that I just showed you?
Yeah, we will find X.
Not X, don't say X. Just say angle C. Okay. You can just
Yeah.
call it angle C instead of saying X. So you don't have to find it because you don't know the measures. You will say that angle C will be equal to angle D. We already know it. Why is it going to be equal? Because the other two sides are also equal. Other two angles are also equal, right?
Yeah.
These two angles are also equal. So these two angles, if they are equal, then that means definitely the third angle is also going to be equal. Yes?
Can you explain again?
Okay, and let me explain it how. Let's say you have two triangles over here. A, B, C, D, E, F. Okay. Over here, this angle is equal to this angle. And they are telling you that this angle is equal to this angle. Okay. And let's just assume that they have some values. Let's say this is 60 degrees, 60 degrees. And then 40 degrees, 40 degrees. Can you tell me what will this angle be? Angle C. This angle C. क्या होगा angle C का measure?
C. If it is, we will give it a name like X or Y or Z, something like that. And then we will say X plus 40 plus 60 gives 180.
Okay, then.
Then we will add 40 and 60, and then we will add X.
What is 60 and 40 when you add it?
100.
100. So basically the third angle, whatever you want to call it, angle C is equal to 180 minus the sum of the other two, 100. What is that?
80 degrees.
80 degrees. Can you find angle F in the other triangle?
Yeah, it will be 80 degrees as well.
Why will it be 80 degrees? Because obviously if these two angles are equal to these two angles, then the third angle will also be the same. Getting it?
Yeah.
That is why we have said over here angle C is equal to angle D. Okay?
Can you explain in this one again?
In this particular question.
Yeah.
Okay. Okay. So A this angle is equal to this angle. Okay? This angle is equal to this angle. So the third angle, will it be Equal?
I understood. No.
Got it, right? So this one will obviously be equal to this one. So now you have, what have you got? You have got one angle, one side, and another angle. Now you no longer need this above this one, angle A and angle F.
Yeah.
Okay, so here we have written angle C is equal to angle D. Reason being, it is the third angle. Yes?
Yeah.
Since the other two angles are also equal. Other two angles are equal. So therefore they are congruent by which rule? Which rule have we applied here? Look carefully.
ASA.
Yes. Therefore, triangle ABC is congruent to triangle FED by ASA rule.
Okay, shall we start the new chapter?
Shall we start the new chapter? Yes. Hiba, in this question, by the way, your try these, I told you na, the try these is a homework. Page number 148, the entire try these is a homework. We've already done the first part of that. The second, third, and fourth you have to do. Okay? Okay, Hiba?
Okay.
Page 148, Kala, try these. Now let's come to the next chapter, which is comparing quantities. Okay, Hiba. So tell me, what do you know about ratios? Yes?
Like adding the numbers.
No. Okay. Ratio basically means, let me give you an example. Let's say I have a triangle here. The length of this triangle is 10 centimeters. And the breadth of this triangle.
It is a rectangle.
I'm sorry. Yes. I've been saying triangle since so long. So I accidentally said triangle. Anyway, so the length of this rectangle is 10 centimeters and breadth is 6 centimeters. So Hiba, if I ask you, what is the ratio of the length to the breadth of this triangle?
10
length
plus 6.
To the breadth means 10 is to 6. Okay. 2 means this symbol.
Okay. So it will be 10 plus.
Not plus, bacha. It's not plus. It's divide. It's 10 by 6. Then you make it into the simplest fraction. Do you remember simplest form?
Yeah.
Make it into the simplest form.
5 by 3.
Very good. 5 by 3. So again, you convert this. This is a fraction. You convert this into the ratio form. This becomes 5 is to 3. So the ratio between, or you can say the ratio of the length to the breadth of this rectangle is 5 is to 3. Okay.
Okay.
All right. Okay. Now, Hiba, let's say if I say that so and so person, or let's say there's a particular girl, she's in, let's say, third grade, okay? Third or, like fourth grade or something. So there's a particular girl whose height is, let's say, 90 centimeters. Her height is 90 centimeters. And her father's height, this is the girl's height, and her father's height is double of that, which is, what is the double of 90? Hiba. Hiba.
Yeah.
What is the double of 90?
180.
180. So her father's height is 180 centimeters. Now I'm asking, if I ask you, what is the ratio of father's height to the girl's height? Then what will you put first?
90 is to 180.
Father's
No,
height
no.
is coming first.
Oh, yeah, sorry. 180 is to 90.
180 is to 90. 180 is to 90 means what? 180 divided by 90.
Yeah.
180 by 90. Your basic your goal over here, when they ask you to write the ratio, is to come to the simplest fraction.
Yeah.
Okay.
So can we cut the zeros?
Exactly. We're going to cut the zeros. Now, what will happen to this 9?
It will be 3 by 6. No, 6 by 3.
No. Okay, fine. 6 by 3. All right. 6 by 3. Next.
6. Sorry. It will be 2 by 1.
2 by 1. Exactly. 2 by 1. Okay. So now the ratio becomes 2 is to 1. This is the ratio.
Okay.
All right. Let's do another one. Find the ratio of 3 kilometers. Just a sec. Okay, Hiba, I will give you a personal Zoom meeting ID. Just join in through that, okay? I have to leave this one.
Okay.
Fine?
Okay.
Yeah, I'm giving you another